We've got a panel now of additional experts who will talk more to the transformation. These are technology experts, and people are going to share with us now how technology can help us unlock this renewable dividend that we spoke about this morning. Moderating our panel is Colleen Regan. Colleen is leading U.S. utilities and market reform at Bloomberg New Energy Finance. Her team analyzes utility strategies, power sector business models, and market designs. Colleen also oversees Bloomberg's research on state and federal climate change matters. So join me in welcoming Colleen and this panel.
Thanks very much to Tom for the introduction. And thank you to my esteemed panelists for joining me this afternoon and joining us to talk about how renewables, how technology can help us maximize the renewable dividend in California. So as we've heard already today, and I'm sure it was no surprise to anyone in this room, I hope, that renewable penetration in California is rapidly increasing. We've had a couple hours already in 2017 where renewables provided more than 2/3 of grid demand. California is far and away the #1 state for rooftop solar, and it's also one of the top markets globally for energy storage. And all of these renewable technologies are going to very likely increase now that we have potential goals of 100% renewable energy by 2045, maybe, and a goal of reducing carbon emissions by 80% from 1990 levels by 2050 on the horizon. So, of course, these are not without challenges. We're familiar with the duck curve. And each incremental megawatt of solar PV that we install displaces less and less gas every year. And we need natural gas to meet the evening peak, as well as to provide essential reliability services that come with, say, swings in frequency or voltage on the grid. So I have a great panel of experts here that can talk about how we can meet these needs of the peak and essential reliability services while also facilitating California's goal of increasing renewable penetration and decarbonizing the economy. So that's it from me. I'm mostly just going to be asking questions now of our panelists. So to kick off, I'd like to sort of frame the problem here and talk about the duck curve. And I'm going to start with Paul, actually. So Ormat has been developing geothermal plants for several decades. And geothermal, as I understand it, has a flexible product which can be very helpful in meeting that evening ramp. As solar comes off rapidly, starting around 4 p.m., load continues to climb. How can geothermal play into this and support more renewables on the grid?
Thank you. As she said, my name is Paul Thompson, and I'm the Executive Director for Government and Regulatory Affairs for Ormat. And yes, Ormat's been in the geothermal business actually for 50 years. You know, that's the secret to an overnight success. And you know, what we've really seen is with the massive penetration of variable energy resources, and that massive penetration is close to 500 megawatts 10 years ago, is now 14 gigawatts in California today. And that has really impacted the energy and capacity prices for those variable energy resources that produce power in that belly of that duck. And so geothermal has always been presumed to be this baseload resource. And California has a strong memory of the geysers and steam going across a turbine and being a baseload resource. And I want you all to think of that 1967 car you were driving 50 years ago, because that's how old those facilities are. 96% of the geothermal facilities built in the last 10 years are a binary technology, and it's what we're trying to reintroduce everyone, and we're calling it Geothermal 2.0, because these geothermal resources use a closed-looped binary system that allows us to keep the well field in full production while ramping or throttling the production from the turbine. So we are 100% flexible and can provide these resources that are desperately needed for the CAISO to deal with these ramps if the markets are there. And we see traditional, ancillary markets for operating reserves, ramping and regulation, but the prices just aren't there to move the market yet to not provide kind of a base load fixed resource. But what we're starting to see is those values rapidly changing. And we have a booth out here in a paper that we just finished that really shows that the combined energy and capacity value for geothermal today in California is worth about $32 a megawatt hour more than variable energy resources or solar PV. So you can take those low-cost solar prices, but when you start to add in those energy and capacity values, those integration costs, we start to see munis buying geothermal again, and that's why we're really excited that it's a re-emerging market. And the discussion earlier about how optimistic are you? We can provide these resources; they're available, and we're going to do that moving forward.
Great, thanks, Paul. I'm sure Mark will have some thoughts on the PV a bit later, but I want to go to Kevin first. So what role can solar thermal play here? So solar PV is very much the ubiquitous solar technology in California, although there are certainly some solar thermal plants. How should we think about Solar Reserve's solar thermal product as different from solar PV and able to meet this evening ramp?
Well, the key with solar thermal clearly is the energy storage part of it, and it's not 10 or 15 minutes worth of energy storage. Our Nevada facility has 10 hours of energy storage, so really bulk energy storage. I think there's a role certainly for PV with batteries for that 10, 15 minutes, 30 minutes, maybe an hour's worth of ramping. But if you're looking at bulk storage, which is a molten salt technology that we're deploying not only here in the U.S., but now we've got contracts in South Africa and Australia and other markets where we're active. That really allows a solar project to act like a conventional power project. So we can dispatch, we can turn on, we can turn off, we can run 24 hours, we can operate as a peaker. So I think when you look at the California market generally, okay, forget about our technology for a bit, the California market now is somewhere in the high 20s on renewable energy. They're headed towards 50% by 2030. We're already aware of the problems we're having with the duck curve and the fact that during some periods of the year and the day we've got excess power that we're spilling over either at zero prices or negative prices. So when you go from 27%, say that's what we're at now, to 50, you're going to have to add thousands and thousands of megawatts of storage. The concept that we're going to be able to convince the consumer, which is, we're a very on-demand kind of consumer, to kind of make those changes. We're going to get a little help from the consumer, but I think largely the renewable energy generation is going to have to go more towards energy storage, whether it's with geothermal technologies, PV plus batteries, or bulk storage with molten salt. I think the next wave, as we look forward to getting to 50% here in California, is going to be a big push for energy storage.
I think that's a really good point. In fact, I saw a recent RFO put out by 2 CCAs in the South Bay area that only wanted solar to submit if it submitted alongside of storage. So that's a really interesting point, and maybe something that we'll be seeing more frequently in California going forward. I want to get a little bit more techie to this second part of the renewable integration play. So the ramp and the duck curve is obviously a significant issue, but on a shorter time frame, we also have this essential reliability services issue. And Mark, I know First Solar recently completed a pilot study with ISO and NREL looking at the ability of solar to actually provide these essential reliability services. So could you tell us a little bit about your experiences with that and how you think solar can compete in this area, which was traditionally expected to be a provision by natural gas plants?
Yeah, sure. So yeah, as you stated, we did do a study recently with NREL and CalISO jointly, taking one of our larger solar power plants, 300 megawatt power plant here in the Southwest, and demonstrated capabilities that previously were not necessarily aware of, or there was a lack of clarity or understanding of the true capabilities of what a solar power plant can do. And again, my reference here is more to utility scale solar power plant. By having the proper power plant controls and given the evolution and what's happened with inverters now, you can operate a solar power plant very much as you can a traditional generating asset. And you can deal with issues such as frequency response, voltage control. You can ramp up, you can ramp down. It's a matter, though, of how you do it. And really what we did and demonstrated is that, look, you have a power plant's 300 megawatts or so of power generation. If you take about 10% of that, think what you got a reserve now. You've got almost a spinning reserve of capacity or energy that you can now optimize against that, and you can provide additional services that traditionally would have only been done and performed by non-renewable assets. And I think that the learnings that we've captured from there has really informed people's views differently around the duck curve and really the amount of ability to further increase solar penetration. I was talking to someone previously, they said a number of years ago, about 4 years ago, almost the entire focus of the conference was around the duck curve and what it ultimately meant to a limitation around solar PV. I think the buzz you're hearing more now is that there is more room that we can go with solar, given the advancements in the technology and the capabilities of a power plant that's going to enable deeper solar penetration than we would otherwise. And it's kind of like, I think Paul may have referenced, 1.0. The original view of solar 1.0 was just basically energy. We needed as much energy as possible. We were trying to optimize against a renewable portfolio obligation and give me as much energy as you can. Solar 2.0, we think, will be more around flexibility and controllability of the energy. And eventually you'll get to solar 3.0, which will be an integration of storage to some extent that will eventually allow you some element around time shifting.
Great, thanks so much, Mark. I want to pull in Ryan now to tell us about the consumers. So one of the things that Ryan brings to the table here is this consumer side of the story. So we've got a more utility scale side, and how do we think about bringing the consumer into the wholesale markets?
Yeah, that's a great question. I would say even today we can bring the consumer into the wholesale markets. Now, whether it's worth it to bring the consumer into the wholesale markets is another question. We focus on really helping project developers and retailers and doing solar and storage systems, so really energy storage, provide them software to help optimize that that storage system. But when we go ahead and do that, we really have been looking at commercial demand charge management, integrating solar and storage together. It's really nice that we're actually at the point now to where solar and storage system at the beginning of 2017 was really a levelized cost of energy of around 14 cents. Now we're getting it down to even to 10 cents a kilowatt hour. Having a firm economic model around solar storage for that end user, that consumer, really great. But also, we now have a really flexible asset. The first panel was talking about that, the demand side flexibility. That's great. So we can go ahead and utilize that. And we can go ahead and aggregate that to get into the markets. We just deployed a 31-home residential solar storage network in Auckland. And the reason for that was solar storage was a good delivery mechanism for the retailer. It's actually with a retailer, but that retailer is related to the utility. And the utility really wanted those assets out there to increase the local SAIDI. So to increase that reliability. It was pretty awesome to actually see kind of the first time we can see where distributed energy resources are now being rationalized for distribution market value. Now, in Australia and New Zealand too, there's actually a unique scenario. It's kind of I figure it's the kind of the far end of deregulation is a place where the retailers are able to provide the end consumers wholesale market prices, so that fluctuation, right? And building into that now, that combined with solar and storage, getting that to the market is really kind of a retailer place, so maybe through the retailers.
That's a great point and ties in nicely to what we heard earlier about providing real-time prices as a signal for consumers. But I want to come back to that Australia example later. But for now, a couple of you have mentioned the economic argument, which is obviously incredibly important. So, Ryan, you mentioned we were looking at 10 cents a kilowatt hour for a solar plus storage on the retail side. Is that correct?
On the commercial side, yeah.
The commercial side, okay. On the utility side, obviously, this is no less important. You're looking at if I just look at wholesale market prices in California, for example, so far in 2017, we've seen peak pricing at around 8 p.m. averaging $68 a megawatt hour, so 68 cents a kilowatt hour. Is that the kind of economics that makes sense for geothermal and solar thermal, and is that competitive with the solar plus storage that you're mentioning as well? So keep in mind, I've just given a number for an average price at 8 p.m., but you still have the average price over the course of the day so far in 2017 has been $32 a megawatt hour. So how do we make the economics of these various technologies work if there's only certain hours of the day in which you see high enough prices to maybe warrant different technologies?
If I can take a stab at it, a geothermal contract was just signed in California with LADWP, and the price is public, and it was 7.5 cents per kilowatt hour, $75 a megawatt hour. I think he said 68 cents a kilowatt hour, and we'll take that too. But that pricing is for a fixed price PPA over a 20-year period. And so I think the discussion really needs to kind of move to, we can provide a different price at a different time, or a different product. So, geothermal's nice. We have a turbine spinning. The binary technology allows us to detach from the well field so we can keep the geothermal resource at 100% production and throttle this turbine to whatever the market demands. And so if there's a time when the market says we only want reactive power, not real power, give us a price signal, and we'll see if we can, over the year, average about 7.5 cents. So again, during that ramp, kind of like solar reserve, we could provide kind of unlimited ramp capability if we knew what the price was going to be at that moment in time. And so I've heard Steve Berberich talk about, kind of multiple time of use rates or different technologies, and I think that's where we need to get creative in the structure for which we procure the power. For too long, we've had a single PPA to one power plant that had to do a certain output, and we're seeing that change. There was a portfolio PPA that looked at multiple resources, which creates even greater flexibility. And in these values are products that we don't have a market yet for. So non-traditional kind of ancillary benefits like inertia or voltage control we talked about. What value do you want to give that? And can we put that on top of or reduce that from the 7.5 cents? So the market is absolutely there. And we're very excited to see kind of fast movers adopt that, like Los Angeles Division of Water and Power. But we also need to see regulators and staffers and the markets say what the value is, and we'll give you the product, and we'll drive that innovation to you. There's been a lot of talk about kind of the policies and carve-outs and things, and the market is going to dictate, I think, those answers, and we're going to provide those products when the market is there. We can do it. First Solar can show what its resources can do. We can do a demonstration and take a project and ramp it from 0 to 100. Our facilities ramp at 30% of their nameplate per minute, faster than a gas peaker. But we're not going to do it unless you give us the right market signal.
Okay, so the market signals are not yet there. Is that what I'm hearing from you?
Yes.
Okay, great. Kevin, do you want to weigh in?
Yeah, let me weigh in a
there.
little bit. And to a certain extent, solar thermal with energy storage has some similar aspects as geothermal. I mean, we have a conventional steam turbine on the back end. Utilities like us, it adds inertia into the system. We can be in hot standby. We can have spinning reserves. We can do all those things that a conventional power plant can do. The difficulty that solar thermal had, earlier, I'll say in the solar boom here in the U.S. has been cost. And PV, the U.S. was a cheap energy market. We had pretty cheap natural gas that could provide backup. But if you want to continue on that path, you're not going to be able to depend on natural gas to meet that. We built our first project with this technology in the world in Nevada, and essentially the market signals didn't exist here in the U.S. to be able to kind of continue that trend. So we went overseas. So we're looking at markets where they don't have $3 natural gas. They have LNG at 6 or 8 or 10. and where they need these technologies are actually holding up demand and are providing demand into the capacity into the market. And so, the Australian market, the Chilean market, the South African market, the Middle East are all looking at this kind of storage technology. And when you look at storage, you gotta if you throw up some PV and you include 20 minutes of storage versus a PV project with 10 hours of storage, there are dramatic differences in prices. So we're actually now, our initial project here was relatively expensive. We've been refining the technology, as has others in the market. And we're now bidding internationally, and we signed a power contract in August in Australia, which was around 6.1 cents US, and that has 8.5 hours of energy storage. We're bidding into the Chilean market. Bids just went in last week. They'll be made public in a couple of weeks, under 5 cents a kilowatt hour for a 24-hour-a-day solar. Now, the Chilean market is crazy solar resources, so we can't replicate that in California, certainly, or Nevada. But certainly in that 6, 7, 8 cent range, you can look at 24-hour-a-day solar with technologies like ours. And I think that's going to be competitive, and it's going to be part of the mix. I think the mix is going to continue. We're still going to be able to put in PV into this market without storage. We're going to be putting in PV with storage. We're going to be looking at storage like ourselves. We're going to be looking at geothermal, and we're going to be looking at demand-side management as well. So,
great. I hope the utilities here are listening about these stories from what's working in international markets. Ryan, so a key part of the economics here does seem to be looking at not just comparing against solar, which has been admittedly the choice of many utilities in California for renewable procurement, but solar plus storage. On your end, on the behind the meter side, are you seeing the economic improvements in solar plus storage costs that you think are going to allow the industry to scale there? And how does Jelly's technology really help consumers to take advantage of that?
Yeah, we're seeing amazing drops in storage and solar storage technologies, really getting to the point of where it can compete relative to other sources, and actually, if done right on the commercial, can actually provide a lower dollar per kilowatt hour PPA. If you go ahead and bring in the demand charge reduction in addition to the kilowatt hour generation. So really we've been really working through getting a lot of the financing structures, getting solar project developers up to speed on how to go ahead and develop these projects. But it has been really interesting. We have a online design tool that we have over 1,000 project developers, and over a couple thousand projects have been put into the hopper to do site-by-site analysis. And really it's this chain of tools, of design tools and automation tools and management tools, which we're looking to give to as many project developers as possible to really kind of scale out the design and deployment of commercial solar and storage systems. So I think those tools are really important for the scaling. We know that the prices are right now in many places. We cover like 10,000 tariffs too, so give a lot of flexibility and like where you can look for projects, not just in California. And kind of tapping onto the last question, I think it's actually ultimately really important to align all the values from behind the meter in the distribution system and then into the market. We could say that it's relatively easy to get aggregated assets into the market today, but getting back to like, what's the real value in the distribution system? How can we really bring that value there? Is a really big question, which is, I know a lot of people are looking at it. We're also, we have a Department of Energy ARPA-E nodes grant, which is all about how do you quickly aggregate 100 distributed assets such that they're doing their thing behind the meter, but can provide services to the grid in a very machine-to-machine automated way. So all of a sudden, like having technologies like local transmission, distribution level energy exchanges, will help us go ahead and align all three of those main values, which I think needs to be on constant focus here.
Great, thanks. We've been talking about energy markets and really how maybe for a number of these technologies, wholesale energy market revenues aren't sufficient and aren't giving the full picture of what these technologies can provide. So ancillary service markets are certainly a very important part of the story. I have two follow-up questions. First, for you, Mark. Obviously, ancillary service provision does entail reducing sales in energy markets most of the time. So if you've bid into an ancillary service market, that generally means you're not generating and selling energy, which means for that particular solar PV plant, you're not earning RECs, or you're not earning what could be great revenues from the energy market. So how does that economic story play out for your projects that you're thinking about? What kind of a price do you need to see in the wholesale energy market to make it worth foregoing that and the RECs to sell into ancillary services?
Yeah, I think you got to start off first with the premise that as we see increased solar penetration, there's going to be some amount of curtailment. And curtailment sometimes is viewed from a negative perspective, but I look at it as, if you think about it as strategic curtailment, the real question is, how do you create value out of that? Okay, and I think the study that E3 has done recently, I think they've referred to as solar is the new hydro, right? It's very similar, right? There's occasional spills that are going to be needed at various points in time. And so knowing that premise, that there's going to be some amount of curtailment that has to happen, which therefore by definition means there's some amount of excess power that would be generated. If you look at it strategically, how do you create value out of that sliver, right? And that's where I think the ancillary services come into play. The challenge, though, is getting the right market design and the right market mechanism in place to properly value the services that can be provided. And I agree 100%. Once we determine what the value is of those services, we'll figure out how do we optimize around that, okay? It's no different than, the comment, just add my view a little bit around with storage and the integration of storage. If you look at PV plus storage today, you're seeing prices as low as 4.5 cents. You're seeing 3 cents, sub 3 cents on the PV side, and somewhere, about 1.50 pennies or so, 2 cents on the storage side. What we're given, though, when we actually look through that, is we're almost given a heat map from the utility's perspective. And they said, these are the hours at which I want that dispatch, and this is the value at which I'm willing to pay for that. And you can optimize around that, and you create the best value equation for the capabilities, and you create solutions. A lot of it's software related and dispatchability and other things that harmonizes relative to what the utility needs and what we can create the best value on. And it'll be no difference with ancillary services. Once we have a better understanding of the market mechanism, the design, and the value creation, we'll be able to determine how do we best harmonize the services that can be provided, knowing that there's going to be some amount of spill or curtailment that by default will happen as we see increased solar penetration.
Okay, thank you for that. Does anybody want to weigh in? Because I have a follow-up question if not.
I'll weigh in a little bit. We're throwing a lot of numbers around on prices, and I read the story on the solar project, the PV with battery at 4.5 cents. The amount of storage that was included in that was pretty tiny. You can take a 3 cent PV price and you can drop a AAA battery in there and say that's got storage. That's not really what the intent is. So if you're truly looking at bulk storage, and each of those types of storage have different roles. So there is certainly value to having PV with 10 minutes of storage or 15 minutes of storage, but it's hard to compare that against 100 megawatts with 10 hours of full load storage versus 100 megawatts with 15 minutes of storage. Tesla's building probably one of the largest, if not the largest, battery storage project in Australia. It's 100 megawatts, okay? I think 70 of the megawatts is for 10 minutes, and 30 of the megawatts are for, I think it's an hour or two, okay? So I think all in, it's around, maybe 100 to 120 megawatt hours of energy storage. That has a role and a reason why it's being put into the South Australian grid. They've had some issues. In addition, then, the South Australian government has contracted with us, which is 150 megawatts with 8.5 hours of full load storage, which is 1,100 megawatts of storage, 10 times the amount of storage, and we have a different role than what they're going to be utilizing for battery storage. So you've got to really look at the amount of storage that's being added into a project and what the purpose of it is, and how big of a difference it's going to make on the grid.
So I want to say one thing though, just to balance it out. The general profile that we're looking at with PV plus storage is 4 hours of storage. Okay, to Kevin's point, it was right. The amount of actually storage that was used, the capacity against the amount of storage was around 20% of the available capacity. But the reality is the technology is going to continue to come down. And if you really look at a lot of the profiles, especially here in the US, 4 hours of storage is going to cover most of your evening peak ramp that you're going to have to address. Completely agree. It won't necessarily address the profile that Kevin's technology will.
Yeah, there's no question that you know, those two different types of technologies are going to be interfacing, and they're going to be integrating in various systems. You know, the grids in California are different than grids in other part of the U.S. and different than they are around the world. And the issue is, what do you do on a cloudy day, kind of? So, you know, 4 hours isn't going to cover you on a cloudy day, but if you've got 10 or 12 hours of storage, maybe that gives you some additional value. So, you know, we can debate the attributes of storage, but I think there's no question that all those technologies have to advance. And all those technologies have to come down if California has a prayer of getting from, you know, 25-30% to 50% by 2030.
I would add on to that, and I would say what makes California so unique, and we heard about it from Chair Nichols this morning, is also the climate overlay. And I think the value, you know, there's greenhouse gas markets, but what we really haven't valued or quantified is the compliance with California policy. And so the question is, as we try to bring on more renewables, you know, I make the analogy of kind of going on a diet all day and then just binging at night. And if you're using solar all day and then you go to simple cycle gas turbines to provide all of your ramp at night, all of that great work you did dieting during the day, you just, you know, throw it out the window. And so the question is, can we get to 50 or 80% without actually seeing greenhouse gas emissions going up with the current technologies that are used to provide for those ramps? And I think that's where, you know, a resource with storage or flexible geothermal 2.0 that could provide kind of unlimited ramp without carbon has not yet, you know, fully taken its value. And I think that is what's setting California apart from some of its western neighbors, is that extra, you know, we heard about it, is that climate policy that the governor always talks about and that ISO is working with, that adds that extra value. And that's why we're really seeing this kind of reemergence, because if we want to see renewables go up and carbon go down, you have very limited resources that can do that and do it effectively for a long period of time. And that's where we're starting to see this incredible value, and utilities procuring more and more flexible, renewable, low-cost resources.
You know, a comment here of what happens when we add software to energy storage. You know, we think about energy storage like a hard drive of energy. And when you start thinking about a hard drive of energy, you start thinking about multiplexing and running multiple, you know, applications through it at the same time. You know, historically, a lot of you know, assets were only used for one thing, maybe two. You know, we are, you know, we're doing 3, 4 applications on using the same asset. Sometimes it's stacked, sometimes it's staggered. But it's really cool. Behind the meter, in front of the meter. You know, so like that, having that type of software, having that type of technologies, whether it's like electrochemical energy storage or thermal energy storage, you know, having that distributed around. I mean, this is why we invented computers in the first place, to do some really hard computations. And when we start kind of putting this type of like, what I'll call a Internet of Energy mindset, you know, around the whole system, we can really start seeing a lot of you know, new use cases, new business models. We can start to fathom how we can optimize the whole chain for any type of stakeholder assembly. So there was a question at the beginning asking about like, what's the name of this? I would propose Internet of Energy. That's where we're kind of going. And it's a great little hook. People can easily put their mind to it, and really does start to open up a lot of different options.
Hopefully Internet of Energy will catch on like Internet of Things, which I feel like I hear every day these days. I want to ask, actually, I heard from both Kevin and Paul about the need, of course, and we alluded to this earlier, the need for renewables to provide that peak, and they can, if they have the right incentives. This past year in the California legislature, we saw what was potentially going to be a very strong clean peak standard, which changed a little bit by the time it was passed, but utilities argued that they didn't need any clean peak standard because they already had incentives to procure renewables or to find ways to procure renewables and storage to meet the evening peak. But we haven't yet seen that at scale. So, how would you respond, any of you can take this, how would you respond to the utilities about this assertion that they don't need any sort of mandate because they're already incentivized to do so?
Well, I would answer that and say, I think the duck curve is a shining example of what happens when you go for least costs and forget about best fit. And so the mandate is questionable because it's hard for legislators to kind of predict the policy impacts of what's going to happen. And we saw that with the solar market. The regulator said we are not going to look at ancillary benefits, or we're going to provide a zero adder for these capacity factors and so forth. And the solar market responded magnificently and built 15 gigawatts of solar. So mandates and policies are tricky. I think the question is the market signals, and you use the word incentives, and I'm not sure that's the right word because we're so used to incentives and tax abatements and things to modify the market. Maybe the market just needs to get the values right without overriding policies that skew that. And as a recovering regulator, we see policies that come in that make us move a market in a way that has, both good and negative outcomes. And I think that's where sometimes we struggle. So, yeah, the top peak is going to be difficult, but that's because they procured so much least cost renewable compliance that now they're struggling with the best fit. And that's where we are today, to make this duck fly and figure out how we get resources that, best fit and are also incredibly valuable.
So how does the market get the value right? Do we need different kinds of markets? Do we need a more formal capacity market in California like they have in other parts of the country? Do we need a more robust ancillary services market? This is for anyone.
Yes, yes, and yes.
Okay.
Yeah, I think it gets, there's been a lot of debate about capacity markets in California, not only for renewable energy, but a lot of the natural gas projects that are struggling with that are operating more on a merchant basis, that are struggling with just kind of staying in business. But to agree with Paul, theoretically the market and the incentives for the utilities now should accommodate that. The difficulty is that attraction for the lowest priced kilowatt hour is hard to turn down and hard to rationalize without the utilities having some kind of backup support from the regulatory structure. So, if it's 3 cents for straight PV with no storage, and it's 6 with a technology that has storage, or 7, it's hard for the utilities to make that choice. So obviously they've been delaying that choice, and so meanwhile the duck curve gets steeper and steeper. And the question is, does it get so bad that everybody just, we get over the hump and it forces everybody to make those rational best fit kind of payments, or do the utilities, would they be better served if the regulatory markets kind of, I'll say, bailed them out a little bit and recognize that yes, it would be cheaper to buy that intermittent generation, but you're going to have to go with a bit more expensive power to make sure that you're meeting the requirements of the grid. So.
Great. Mark, I think, wanted to add in there.
Yeah, I was just going to say, I think you got to balance the equation a little bit, because it's best fit at the optimal cost profile, right? I think that has to be brought into the equation. And I think at least some of the conversations that I've had with utilities, and even in Arizona was looking at a clean peak kind of pricing profile. And the reality is, I think what people are concerned with is that we all sit up here and we agree that the cost of storage is coming down. And there's a view that it's going to continue to come down. And that type of construct would potentially result in them taking a technology risk, or potentially getting out in front of the curve a little bit when the cost curve for storage could be coming down. There's some embedded optionality and value that sits within the existing resource today, as we sort of just referenced, right? controllable and flexible solar can add incremental value, and it can even reduce the ramp in the early evening hours. Because if we focus on this with some amount of curtailment, and then you release that curtailment as you start to ramp into the early evening hours, you've basically shaved or you flattened the profile of the ramp to some extent. So then the question ends up being, well, what is the cost, the value creation of that curtailment relative to the cost of the ramp? Right, and optimizing around that. And I think that's part of what needs to be done here that hasn't fully been thought through. It's not only just the optimal the best fit, but it's what is it at the optimal cost structure. And I think there's a huge educational process that still needs to happen yet.
And if I could just build on that, I agree with you, and I think it's so critically important to get the data right. And the regulators, I'll give you the example. The CPUC right now is working on this resolve model, which is kind of a capacity expansion model. And they have a base case for geothermal using 10-year-old data saying it's $5,000 kilowatt, and therefore, they have an expectation that we should build or could build without seeing an increase in greenhouse gas costs of 200 megawatts. That data is antiquated, but then the problem is you come out of the CPUC with a policy that says we need 200 megawatts. If we change that value by $1,500 to $3,500 a kW, the model drastically changes, and you can develop 1,200 megawatts of geothermal, offset 3,000 megawatts of solar, 600 megawatts of storage, all while reducing greenhouse gas costs moving forward. And so, it takes me back to your point on be very, very careful in trying to tinker with those markets, because a very small, data point can have an extravagant difference in the projected outcome. And this is where, we have to get the right data in front of these folks. And unfortunately, sometimes you look back at the last docket or the last project that was proposed, and I can't tell you how many people tell me that geothermal is baseload. It costs 10 cents, and they've seen it at the geysers. And it's just, we've got to change that thinking, and you have to be, Bloomberg Energy Finance, and I think you heard, Michael at lunch talk about it, that the new data is critically important. The market is changing so fast, and if you try to set mandates or start to tinker with those market mechanisms, be careful, because, you might end up with a result that you didn't expect or isn't quite right because you've tried to alter the market when you didn't just, say, what's the value today for ramping, for frequency regulation, whatever it may be, or inertia, and then let the innovation come to you.
Ryan.
One of those new data points, which has just really started to affect us here over the past couple of weeks, is Southern California utilities shifting of their peak time in the rates. So all of a sudden now, all the commercial, industrial, solar storage systems that we're doing, we're not evaluating them based on the current rate structure. It's this more peak rate structure. So all of a sudden, a shift like that now all of a sudden is like having systems designed to optimize around that rate structure, which effectively will give you load reduction during those ramping times. So that's
And we have a paper at our booth again that looks at, the CPUC for the first time in years started really focusing on the effective load carrying capability of different technologies with the changing peaks. And, there was a given, it was solar had a 65% capacity factor. Take it or leave it. And then when they started really looking at it today with the duck curve and so forth, they said, well, it's maybe more like 40%. And then when they said, well, let's look at marginal new solar, maybe it's closer to 20%. And when they said, let's look at it at net peak, it's like 1%. And so those have drastic valuation changes that are going to affect this market, and we're going to see it, no matter what we do. You're going to see companies respond to that, and I think that's why we're very bullish and excited to see people evaluating that and looking at this new market in California that's just so far ahead of other states, because you're grappling with something no one else has really been met with, which is this unbelievable influx of variable energy technologies.
Okay, so I'm hearing that we need to be careful about tinkering with market structure and market design, at the same time that it would be pretty nice, actually, if we had capacity markets here in California.
Yeah, I mean, if you look outside of the U.S. and you look at some other markets, let the markets decide is kind of fine with fast food or something like that. But if you're looking at keeping your lights on and keeping your food cold and keeping hospitals running, I'm not I'm a markets guy, but I'm not sure that I want to depend 100% on the markets to make sure that life support systems in hospitals and lights and air conditioning and heating and those kinds of things are determined solely by the market, okay? And if we happen to run out, oh well, market decided that it didn't make sense to operate for that hour at 2 o'clock in the morning because prices were too high or too low or whatever. So yes, markets you need to let markets work, but that oversight and that regulatory structure has to make sure that as the duck curve continues to get more and more, I'll say, out of control, that it doesn't actually start affecting reliability of supply. And in keeping with climate change requirements and goals and those kinds of things. So it's a very delicate balance, okay? That's not my job is to do that. My job is to respond to markets and respond to regulatory structures. A lot of people in this room, that is their job, is to figure out that balance between market issues and regulatory issues to make sure that the critical resource in our lives stays on. And that's the tough part of this going forward.
Absolutely. We have mentioned quite a bit about other markets, so I'd like to take just a little bit to talk about how operating in different markets, what could California learn from other places around the world? We've got, all of you have operated in places outside of California, so are there things that California could learn from Chile, from ERCOT, from Australia?
Yeah, one of the things, maybe I'll let someone else talk since I just a little bit of a, we're active in a lot of different markets. We're active in the Middle East, which is a large market, obviously, that has a lot of fossil fuels and oil, and they're moving pretty rapidly towards solar. We're very active in the Chilean market. What's interesting about how the Chilean market holds their bid structures is they look at various blocks. So they're actually requiring people to bid 24-hour blocks. So you can bid the daytime only block if you want to bid a PV only project, or you can bid a 24-hour block, and then you have to decide how you're going to provide that resource. Either you're going to take market risk and buy and sell when you're not generating, or you're going to combine PV plus batteries, maybe with some geothermal, maybe with some wind, or you're going to provide a facility that can truly provide 24-hour a day renewables. And those markets are competing that's not just renewable energy bids, those are all resources. So you're competing against coal, very little chance of new coal getting built in Chile or many of these other markets, against natural gas and others. So they are trying to let the markets decide, but at the same time dictating that some of those resources have to provide full coverage of the grid.
The only thing I would just add to that a little bit, I actually see it the other way around. Most markets are looking to California, right? Because California is on the leading edge, right? And they're dealing with issues that others are still going to evolve into. Whether it's states here in the US or countries around the world. I mean, the only place you're going to see PV penetration anywhere comparable is going to be in Germany, right? Most other markets you're going to see that they're much lower than, call it the 30% that California's at right now. So everyone's looking to California, in particular in the States. So when we're dealing with utility that's somewhat on the early innings of their evolution into PV and solar renewables, is everybody wants to know how is California going to create a sustainable market, right? How are they going to enable the solar penetration to a level much higher than where they are right now? How ultimately does the storage sort of evolve into the mix? The only thing I would say that I see in some markets internationally, we do see in some cases a time of day or even a time of year differentiator around pricing, because the value of the product, of the energy that's being generated at various times of day or points in time during the year. Summer months, obviously, in general, when there's a higher need for energy, you'll see a different value equation on that. So I do think that having that type of construct would be very helpful. Similar to what Kevin's saying around Chile. We do obviously have some projects in Chile, and they do have these time blocks, A, B, and C blocks, and everyone is valued differently because the value of the energy should be considered differently depending on the need in those various times of the day.
Sorry, Mark, just a quick clarification. The differing values on time of day or time of year, you're referring to PPA prices specifically? specifically? Or?
Tariff structures or PPA type structures where there's actually a differentiation around how the energy is valued based off the time of day it's delivered or potentially during the time of year.
They force people to bid into a block, and you have a contractual deliverability requirement, so your price is based on the fact that you can deliver during these peak periods.
Right. We did see that in California with the procurement through the RPS. There were PPA multipliers included for various times of the day. Is the issue there that the numbers were just off, or?
Yeah, you know, it's a question I asked my team, and nobody really has the answer to. I asked that same question because we used to have those constructs in the early PPAs, right? That we would see that time of day type of multiplier and the like. And then what's evolved though is that most of the PPAs that we see now, at least that are coming through RFPs, are no escalation generally and flat pricing throughout the year.
Well, and I think that made sense because when solar was nascent, it provided energy and capacity when you needed it most at your super peak, and there was a multiplier value there. And then it just changed rapidly. And I think scholars and people in this room have written papers about the penetration rate of variable energy resources and how quickly that changes the value. What you've seen in California that you haven't seen anywhere else is how quickly those values can change with the penetration of certain resources. And I would just take kind of a regional approach as a regulator from a nearby bordering state. We don't always look to California for what we can learn, but maybe what we shouldn't do. And, I think it goes to kind of the regional approach, and I think we're looking at finding equilibrium, and I would use Nevada as a reference case of a state that is predominantly naturally powered by natural gas. Its RPS is made up of about 75% geothermal. When they started procuring it, in the early 80s, they can absorb and take a ton of solar today, and we see them buying solar, hundreds of megawatts in that 2 to 3 cent range, and the value and the capacity and the multipliers are absolutely there because of where their market is today. And we see California kind of at the opposite end of that spectrum, looking for flexible renewable resources that don't provide emissions because they've, already OD'd, if you will, on those variable energy resources. And I think that's, a case for how do we create a more efficient, effective, regional market to share some of those resources so that we're not trying to recover from, too much. My grandmother always said moderation in all things, and I think, that applies to certain technologies as well, and we're trying to find that equilibrium and rebalance this market, and other emerging markets could be fantastic places for additional solar with storage as they look to evolve and maybe adopt climate policies as they move forward.
I'd like to come back to the regionalization point in a second, but I did want to see if Ryan wanted to weigh in about your experiences operating down under.
Yeah, absolutely. What's been really interesting and eye-opening is in New Zealand and Australia is about 10 years ahead in deregulation than the United States. So you want to start taking a look at what happens in the limit of deregulation. The utility that's there, they're actually starting to think about, N+1, that's a service they offer, right? They offer N, right? Anything they can do to reduce their operating costs is something that can then actually increase their margins. So what they've also been introducing is what they would call a hybrid investment model. Right? Not just investing in 40-year assets that have lots of stranded capacity on them, but also investing in 5-year assets or purchasing services from DERs such that they don't have to have that operational cost of capital that year rather than procure those services. And so combining those two models is now more networks thinking. One of the utilities that we work with also runs the fiber optic system, right? So they're already thinking about managing bandwidth. And once we start getting the idea of like managing bandwidth and unit commitment and scheduling within the distribution system, then we've actually started to do something that is actually going to be able to build that bridge from those behind the meter assets that can be scheduled and dispatched also. And it will interface into a transmission or to an ISO system, which is also managed from unit commitment and scheduled. So that's why. Then we also see that starting to happen in the UK, right? And then also in Japan. And so that's why we set up office in Australia, because these models are coming through. And just to kind of build on that, those models will be really pushed not but just by your traditional retailers, but it might be the Amazons, it might be Salesforce backing a handful of companies. You know, these digital energy retail services that really make up the other side of a fully deregulated utility is going to make things really interesting. A lot of different energy service providers now. I don't know how many network things you have in your house. I'm a little bit geek for it, so I have 28 network things in my house, right? Now, I'm totally happy to give that to someone who wants to aggregate that and use those as controllable loads, right? And so then the question is, like, what can we do to lower the transaction costs? And so even some places in Australia, they're experimenting with peer-to-peer energy exchange right now. And again, a lot of that's due to the transparency that they have to be able to see what the market prices are and participate like that. So that clear pricing signal. So yeah, I think the things that we're seeing in Australia, New Zealand, Japan, the UK, especially Japan, because it's just liberalizing right now. They're just setting up their capacity and their regulation markets. You know, things that we can bring over there to see how quickly things can adopt. It's going to be really interesting.
Great, thanks for that, Ryan. So I'd like to come back to the regionalization point that Paul made, because obviously the potential Western regionalization of the power markets is something that's a hot topic these days and certainly hotly debated. And I just wanted to hear your thoughts on any of you on what you think that means for allowing us to use and increase technology to really maximize this renewable dividend we've been talking about today. Do you think the regionalization helps?
I'll take it first, I guess. Look, I think anywhere you can go that you can optimize around the resource and create the best value equation around that resource is accretive and is value added, right? So I don't think there's any reason we shouldn't try to do that. I mean, there's a whole bunch of complexity, and I understand that, the political issues and everything else that you would have to be dealt with, but really to optimize the value around the resource, I think you ought to try to find ways that you can create more of a regional platform where that resource can be consumed.
Yeah, I would agree with that 100%. I think yes, there's going to be a lot of issues with politics, but providing a broader regional network where you have different issues in LA than you have in Portland or Seattle, and different weather and all kinds of different things. So it can ultimately provide for a more robust system. The politics are going to be difficult. The technology has some issues, but providing that broader regional grid will, essentially provides, I'll say, diversification of the resources that are available in those different markets.
This is where I think I would just touch on the fact that it's going to happen no matter how much politics wants to get in the way. And we are seeing, we saw a lot of large customers leave the Nevada service territory and buy power, not from Nevada, but from other parts of the country, and are bringing in those electrons. We're seeing large portfolio projects move power from state to state, regardless of the balancing authority, because people are purchasing that power because it's at a better price and a better rate and bringing it in. So, I think it's going to happen. The question is, do you want to kind of have it in an organized fashion under kind of a rulemaking rubric, or do you want to see it kind of, get kind of cobbled together and piecemealed together moving forward? And I think, it goes back to a comment. I think there are ways to do it. And having been an energy advisor to a governor, I think there are some conversations that can be had at that level. Instead of, we know how to do it and we're here to save you, the conversation could be, we have some issues. You could help us fix them. And there's a lot of money to be made while reducing rates for, ratepayers in our service territories, and I think that's going to be driving the conversation moving forward. But absolutely, I mean, the problem you're trying to solve is magnified when you isolate yourself to an island and try to fix it, all by yourself, or mandate large storage projects or something, instead of looking at all of the resources available in the region. How do you shift power? How do you do it most economically and maximize the dividend from your renewables, moving forward?
I'll say the term complexity was used a number of times here, and I'd like to just remind us that we invented computers to deal with complexity, and that's a really important aspect here. Is because also using software and going to that level actually provides us a level of transparency we've never really had before. And again, it's that level of transparency that we really need to see what all the values along the chain are. So, yes.
So
If it was easy, everyone would do it.
So there's some complexity, but we're all in favor. All right. If you guys could disagree on a few more things, it might have been a little bit more entertaining for the audience. That's it for me, except maybe one last question. So let's pretend we're here for the 19th ISO Stakeholder Symposium. Do you think we're still on stage talking about the duck curve? Is it a whole different kind of animal by then? I'm not sure. Maybe it's a cow or a snake. Do you think that this is still an issue, or have we solved it?
I think we will. It might not look the same as the duck curve looks like now. I think in the morning session, one of the, and it was a very good session. One of the participants made the point about should we be passing more of this on to the consumers? Okay, which number one, to get in, and a little bit of that's being done in a lot of markets now, is you higher pricing during higher demand periods. But if you actually did it the way that it would necessary to actually move markets, to move the pricing, it would be pretty dramatic. And you'd have this whole surge pricing. Number one is, would it affect our demand? Okay, I mean, as I mentioned earlier, we're becoming more and more of an on-demand society. So how do you convince somebody when they get home from work, don't throw your clothes in the wash then, wait until 10 o'clock at night when prices are lower? There's going to have to be pretty dramatic changes in pricing. I mean, when you look at on-demand TV and Uber, and the fact that we can get something from Amazon in 24 hours, that comes across the country, we're not moving to the place where consumers are going to wait for services. So you're going to get a little bit of help from the consumers, and you're going to be able to do some of the passive stuff, like maybe your refrigerator runs it when it's supposed to run, and I don't have to really worry about it. But actually, to truly expect the consumer is going to change their behavior is not going to help very much. So we're going to continue to get this demand, on-peak, off-peak demand issue that's going to have a big play. And the speaker at lunch also talked about how batteries in cars affect that as well. And that's going to be dramatic, is can we get to the point where batteries in cars are actually helping the system instead of working against it? And that is yet to be determined. I think we'll be debating that for a while.
I think we're a little more, I would say, optimistic that we're not going to see a big curve. Ormat recently acquired a company called Veridity Energy Solutions based out of Pennsylvania that started as an energy arbitrage company working in the PJM, ERCOT markets, and was really the brainchild of Audrey Zibelman, the former commissioner of New York. And the reason we did that was because we looked at how do we reduce energy consumption? How do we provide kind of stackable solutions so we can provide reducing demand charges like you talked about, but also providing regulation, providing energy storage, and providing the electron generation product or the power generation as well. And I think you're going to see companies emulate that and what Ormat has done, and say, how do we provide a holistic kind of global solution to this issue as we move forward? And I don't think you're going to see, which ISO Symposium are we at? When's 19? 9. How far away is that? 9, 10 years, thank you. I think you're going to see more and more companies doing that and saying, we don't just provide, resource X, we provide this entire list of options. And, there's a great example, Veridity worked with the MARC rapid transit system to put in energy storage, and the initial thought was just to avoid the demand charge for when the trains are taken off, but that's such a limited part of the day that then they went into frequency regulation. And that's just one small part of the future of interlocking all of these pieces as we move forward to make them as valuable and as efficient as possible. And I think in 10 years we're going to have a very different looking companies up here that are providing a simple solution to the complexity of things through dispatch, through all these innovations that are just coming at us so rapidly right now.
Yeah, I would just say, because I did allude to in one of my comments, is that if you looked at the discussion around the duck curve 4 years ago to where it is now, I think even in that 4-year period of time, it's changed. Now, the issue has gotten more challenging, but the perception and understanding of the potential solutions that can resolve it or address it are probably getting more clearer now. So, in 9 or 10 years from now, I don't think we're really going to be thinking about it from that perspective. There's a lot of really smart people, and a lot of creativity, and a lot of intellectual horsepower that's focused on this, and I'm optimistic and confident that we're going to find a solution for it, and it's not going to look anywhere near like it does today.
A friend of mine texted me and says, "Hey, when do we start duck hunting?" Right? And I think that's actually really interesting because it's like duck hunting to specific assets, because it's really just one big stack at any moment. And then we start thinking about transaction costs, right? Like, what can we do to actually get transaction costs? And so we're doing a number of things around smart contracts to enable like machine-to-machine transactions. And if you think about that, the example I use is, will we get to the point one day where it's worth turning off a 100-watt light bulb, even though there's no 100-watt light bulbs anymore, for an hour, right? At 10 cents a kilowatt hour. That means it's worth 1 penny, which means all of the compute, all of the stakeholders, all the Amazon Web Services costs, all the licenses all have to come in tenths of a penny. And can we get transactions down to where you can have a transaction like that, to where you can aggregate those up and make it worth that? And so there's some very interesting database technologies and fast, transaction technologies coming out there that are going to change that world, and maybe. So I'll be interested to see, like, what's the size of the duck that we're hunting in 10 years?
But the issue is, will that tenth of a penny cause somebody to act differently? My view is very few of us in the room will act differently for a penny a kilowatt hour, even for 10 cents a kilowatt hour. Very few are going to act differently with how they act throughout the day.
I think it's not about acting differently, right? It's about having all my 28 things in my home, which
the
are
automatic
networked,
issues.
And then just
the automatic issues are going to work. Like I said, if my refrigerator will stay cold 24 hours a day, if it runs at 6 a.m. and 12 p.m. and 7 p.m., that's great. I'll leave it at that, but I don't want to be in charge of that.
Right, so take this example of the OEMs, because of networking technologies, now can actually sell their thing as a service. Right, so now you're not buying a refrigerator, you're buying cold food as a service, and as long as they provide you cold food. Now, if we have a kilowatt hour in every refrigerator, and there's a company, making sure that your refrigerator is cold and operating it for the grid services, I might give you a free refrigerator.
Well, the energy markets here in California, we've got a duck problem that's gotten worse over the years. I agree with Mark. We understand it more, but I don't see us doing that much to solve it. Okay, yes, there's technologies that are coming on that can help solve that, but unless the market / regulators understand that we need to add storage to this market, we need to add flexible generation that's renewable, it's not going to change. And that's my concern, is that we're nibbling around the edges, a little bit of here, a little bit of there, but we're talking, thousands of megawatts of storage, flexible renewable energy generation if we're going to meet our goals.
All right. That was a great way to end it. Thanks for being the contrarian here, Kevin.
Sure.
And please join me in thanking our panel for joining us today.